Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to just go through some examples of simplifying expressions that have imaginary values or imaginary parts to them. So first of all, let's take a look at this one here, the square root of negative 200. So let's rewrite it here for just a moment. Let's write that negative 1 times 200, and I guess we'll go ahead and break this up a little bit. Let's break that 200 into 2 times 100. Now, when we go through and look at these pieces, this has a nice even, nice square root, 10. 2 there's nothing to do with, we'll just leave that root 2, and the square root of negative 1 is the imaginary number I. So we can bring out a 10 and an I, and then this 2 stays under the radical, and that's about all we can do with that. Again, where I is the value such that I squared is equal to minus 1, referred to as an imaginary number. All right, looking over to the right here, or middle, I should say. Square root of 16 is 4. Let's take this minus 25, and we can write that minus 1 times 25. And now the square root of minus 1 is, again, I, and the square root of 25 is 5. Now, 4 plus I times 5 is just fine. Usually we write it like this, 4 plus 5i just kind of sounds better, but again, multiplication is commutative, associative, all that good things. We could technically leave it as I times 5, and no worries. All right, let's look at this example over on the right here. 50 minus square root of negative 98. All right, well, the 50, let's see, we can write that 25 times 2, where 25 is 5 squared. The negative 98, we can write that negative 1 times, let's see, how about 49 times 2? Okay, square root of 25 is 5, and this 2, we can't take the square root of that, so that stays under the radical. Okay, square root of negative 1 is I. I'm going to write that last. Let's see, square root of 49 is 7, so basically that can come out in front. And then again, square root of negative 1 is I. And this 2 just has to stay under the radical. And there we have it. That's about as much as we could do. If we wanted to, we could factor that root 2 out, but there's really no reason to. And actually, it'd probably be better just to leave it like this because it's in the form of a standard complex number. Remember that complex numbers, z, can be written a plus bi, where a is the real part, and the bi is the imaginary part. And that's exactly what we have here. We've got 5 root 2 is the real part, and then negative 7 root 2 times I is the imaginary part. So again, this video is just meant to be a short video on simplifying expressions that have imaginary numbers. I hope you enjoyed it. Have a great day.